Today we will start Geographic Information System, that is GIS, right? So in this lecture we will cover the basics of GIS as well as how we are using this GIS function in our remote sensing, because frankly speaking you cannot separate this remote sensing and GIS when you are involved in satellite image or airborne image interpretation, right? GIS and remote sensing both are complementing each other. So here let us see what exactly GIS mean. So what is the definition of GIS? GIS is a system designed to capture, store, manipulate, analyze, manage and present all types of spatial or geographical data, right? It is very important here to note that we are talking about the geographical or spatial data. So whenever we are involving GIS analysis, we always use spatial data or geographical data. Let us consider some parameters like X, Y and Z. But here this X, Y, Z can be any parameter, but we don't have any location values attached to these parameters. But in this GIS we need to have location information in terms of either latitude, longitude or the location name. If you know that place, it will be very easy to locate them in your map where exactly you have collected or measured these parameters, right? So this is the benefit of using GIS for your attribute data. So here I have mentioned spatial and geographical. So this was in terms of field investigated result. Now you think of using remote sensing data. So in remote sensing data, as we know, we have location value attached to each of the pixel. So here in GIS what we are doing, we are capturing, storing, manipulating, analyzing, managing and presenting. So we are doing everything from the scratch. So the whole process comes under GIS, right? So whenever we say I am working in GIS domain, it includes all these parameters, right? In other words, GIS allows to integrate many data in a single map, which enables to visualize, question, analyze and interpret data to understand relationship, pattern and trends more efficiently. If you have 10 parameters collected in separately from a field during a field investigation, and if you see them independently and separately, what will happen? You will end up analyzing only those parameters. But if you have a flexibility or if you can bring them in GIS environment where you can integrate n number of data sets together for an area, then it will be easy to understand that particular study area in terms of your application, right? So here GIS gives you a platform where you can visualize the data, you can run some queries, you can analyze the data, you can interpret the data. And why we are doing that? To understand the relationship between different parameters, then patterns. You need to decide if this particular study area is having some pattern in terms of some parameters, then accordingly decision has to be made. And trends can also be established here, right? For GIS, Geographical Information System is an organized collection of computer hardware, software, geographic data and a personnel who can capture, store, update, manipulate, analyze and display the data as information. So here basically what we are doing, we are using these things to store and visualize the data, but here this is your input data, it can be spatial data or geographic data. And the personnel, here you can have groups of people who are involved in capturing the data. So one team will do capturing, another team may use to store them, another team can just update the information at regular interval, another team or another group of people, they can play with this data to analyze and display. So that's why here you have an environment of people as well as the software and computer where everything is integrated together, right? In GIS system, basically a spatial data or geographical data is needed, but for what? To analyze and interpret or visualize them, to establish some relationship or pattern or trends. But for all these processes, you need to have your input data. So first let us understand what is the difference between data and information, because here we are calling it geographic information system, but the input is your data. So let us understand what exactly data mean and information means, right? So the first question which I am going to ask is, are they different or same? So the answer is they are different. How they are different? Data is of little use unless it is transformed into an information. So let us assume that you have collected groundwater depth for an area, and if you don't analyze that data, what is the use of that? That is meaningless. You don't have anything from that data. So whenever you are involved in GIS, we need to analyze that data. So that's why we need to understand what is the difference between data and information. The information is an answer to a query based on raw data. So basically we want to transform this data into information, right? That is the process. So here how we do that? We study that collected information or data and then we derive information. We transform data into information through the use of an information system. I have an example for you. So you can see this is your data, right? So these are some numbers. So if I am not expert in analyzing these numbers, for me it is useless. For me it may be meaningless data, but for you it may be of use, right? Because you know how to interpret this data. So you can see here, after processing you can transform this data into information and you can identify some letters here, right? So that is the difference between data and information. I hope it is clear to you. Now what do you mean by information system? I hope you have understood the difference between data and information, but nowadays everybody is talking about information system. So what exactly that information system mean, right? So for that I have a example. Again, this is a pictorial representation. So whenever you have a doubt, like if you want to learn some topic or you want to know what is the meaning of remote sensing or what is the meaning of remote sensing in Hindi, right? Then what you do, immediately nowadays we Google it, and whenever we send a query to information system, you will receive an answer. I am not saying that all the time whatever you get that is 100% correct, but you get some answers, and based on your intellectual ability you interpret that answer and then you have a option either to use that answer or not, right? So here this particular person is having some query, maybe something related to maths, then he wants to learn and then he send this query to this information system, and the information system understand that question and then it provides some answer. So that is the meaning of your information system. So information system is system which can provide you answers about your questions. Now these are very common example of information system. So you can see whenever you want to call a person, you look for the telephone directory, right? So you have their name, you just go to that page and then you identify the number and then call them. So that is the best example of information system. Now here in library, all of us are using this library. So here, how do you identify the position of a book? By using the catalog. Either it will be online or maybe offline, right? So you just search with the letters of that book, then you identify which rack, which sequence they are lying, right? And then you go and pick up that book. So that is the best example of your information system. And nowadays this Google, whenever you search, when you want to learn something or when you want to know about some topic or some subject, you just Google, you will get some answers and then you analyze whether it is correct or wrong. So this was related to information system. Now let us see what is the difference between information system and digital information system. So this figure itself can explain what is the meaning of digital information system. So nowadays all our mobile phone, desktop, PCs or hard disks are connected with this internet, right? And through internet you are sending a query and you are getting an answer. So that is the meaning of digital information system. Suppose you have done a very good research, but everything is in hard copy and it is lying in your table. In that case, you cannot access or nobody else can access that information from your table. So that will be your hard copy information. So whenever you convert them to digital form and then you make them available in the internet, and if anybody across the world can access that, that can qualify this digital information system, right? Digital information system also applies for a group of people. So maybe you have a very restricted information which can be accessed only by few individuals. That also qualifies this digital information system. So nowadays whenever you go to field, you collect some data and from there itself you send to your office or lab, right? Or maybe somebody else has completed that field investigation and you want to access, it can come to you through this digital information system. So slowly we are evolving ourselves and we don't want to repeat the same exercise again and again. So we want to make all our data sets available in the internet or maybe in our server. So digital information system is an integration of hardware and software to enable advanced research, communication, education, awareness, etc. Now you have understood what is the difference between data and information, then information system, then digital information system. Now we are having geographic information system. So in geographic information system, what extra we have? We have location, that is the additional value which has to be in this GIS domain, right? So let us see what are the different steps or different components of this GIS. So GIS acquisition or procurement, so scanning of hard copy maps, manual digitization of scanned map, remote sensing images, these are part of your input data. Then in GIS we also make sure of the database management. So in database management you have data security, data integrity, data storage, data retrieval, data update. So once you have made a database for, let us say, what is the water quality of maybe Delhi. So what kind of water people are drinking in Delhi. So that you have done an extensive survey in 2019 and you have made a very good database. So after 5 years, will it be same? No. It will either improve or it will be worse, right? So in that case, you need to keep updating this database if you want to really represent this area characteristics. So for that data security, first point, So whether this data is allowed to use by anyone or only to a individual or only to a certain group of people, that you can manage by using some registration process, or there are many other methods. Then data integrity. What is the integrity of your data, whether it is very good or whether what is the accuracy, what methods you have used. So all those things should be available in your portal. Then data storage. How do you store data? How you are making it available to others, whether it takes time or it will be very fast. Then data retrieval, the same thing which I have explained. How do you retrieve? By a registration process, or maybe someone send you an email, then you send them a link from where they can download the data. Then data update. I gave you one example for this database update. So if you want to keep updating this database, then people may refer only your particular portal to get the information about the water quality of Delhi, right? Next is qualitative and quantitative analysis. So data analysis and interpretation, whether you have provided any flexibility to analyze such information which are available in your database, and what methods you are using. And then next point is visualization or result. So how do you represent this result? So because if you put a tabular data for, let us say, water quality of Delhi city, so visualization plays very critical role in this GIS, because you need to decide what method or what form you are going to use to represent your data, so that the audience can understand it very easy. Now what are the different applications of this geographical information system? So first one is resource exploration, which is here. Then next is for engineering drawing, then demographic analysis, then topography and geoprocess modeling, watershed analysis, logistic routing, then site selection, and many more. Because I cannot list all the application here, because the application of GIS nowadays is in all the application in all the domain, right? Now let us understand what type of data we are using in this GIS. So for that we need to see what are the major categories of data and how we are using this in GIS. So first one is your raster data. So raster data is nothing but your remote sensing data in the form of images. So here raster data sets are basically those data set which has grid or cell or pixels or elements, right? So if you have such elements in your data, that means they qualifies for the raster data. So here in the raster data you can see, you can easily find the pixels, right? The next type of data is vector, where you have point, line and polygon. So I guess you are familiar with point, line and polygon. Now let us see how exactly it is different from raster. So here you can see this is one point, this is some lines, and these are polygons. So what is the difference between these three? So points are like individual feature, and 2 points if they are connected with a line, right? So a line will have 2 points, and if this is enclosed, then they are known as polygons. So here you can see these are polygons. Let us understand what benefits or advantages we have when we have raster data and what advantages we have when we have vector data. So we will start with raster data. Here we store images as row and columns of digital number or values for each cell. That exactly matches with our remote sensing data. The next point is area divided into pixels. Digital output of any camera or sensor is raster data. Based on the map, scale or spatial resolution, each pixel represents the area. Very useful in representing the continuous variation or thematic or dense data. So, when you are having too many data set, this kind of representation or the raster data type is very useful. Very simple data structure, because in one column you will have latitude, longitude and digital number, right, and then you can represent and you can store this in your pixels. So, each pixel will have 3 values, right. So, like that you can store this raster data, and requires large storage space because this area is divided into small pixels and each pixel will have associated values, and those values need to be stored in your hard disk. So, it requires large space. Commonly used data formats are JPEG, TIFF, GeoTIFF, that you already know. In vector data, we have the simplest element, that is known as point. So, you have point data, and the next one is set of connected points are known as lines, and third one is set of connected lines and which is basically enclosed, they are known as polygons, right. So, here you have 3 different types of data in vector. So, you have vector point, vector line or vector polygon. In vector data, area separates with different polygon. Statistics can be estimated for an individual line or polygon. So, that is very easy here. Very useful in representing the discrete data. Now, let us understand what exactly it means when we are talking about raster and vector data. So, discrete means where you can find out one particular point where the values are ending or the class is ending. So, let us see some example. This is one area where you have a forest class and you have a water body, right. So, forest will not end exactly at this particular point. There may be some trees here, right. So, somewhere it may be less or more. In vector data, you have point, line and polygon to represent such features. So, when you are using that, you have a restriction, like you will decide a boundary from where you will say this is forest, this is non-forest, right. So, in that case, you are making a boundary for the discrete class. But in case if there is a mixture, like here, if this is a wetland and here the classes are overlapping. So, slowly it is getting converted into another class. So, in that case what will happen? This vector lines will not be useful. But in case if you know that this is the boundary of my class, then this vector data is very, very good. So, very useful in representing the discrete data, where you know exactly where is your boundary. But in case of continuous data, raster is good because you will have pixels here, and it does not matter how many pixels are coming here or there. So, you can always represent continuous data better with raster data and discrete with vector data. That is the advantage when you are dealing with vector and raster data. Now, the next point in vector data is many attributes can be associated with each polygon. So, suppose if this is your map, so these are the polygons or lines or points. So, for each point you will have x, y, right, what is the location, then what is the unique ID. So, let us say z, and then you can mix many columns here and you can save different parameters estimated or measured in the field or derived from any other sources. So this kind of information you can easily save here for a given particular location. But in raster data it will be difficult, because the raster basically we have pixel, and the pixel size may be 30 by 30 meter or 2 by 2 meter or 0.5 by 0.5 meter. So the information which has been collected from the field may not be for the 30 by 30 meter or 2 by 2 meter or 0.5 by 0.5 meter. So in that case you need to pinpoint where exactly this data has been collected. So in that case vector is very good. Next is very complex data structure, because you can save many columns and many parameters. Good representation of data and map, because here you can provide different colors, texture. So the representation or the visualization of your data will be very good. Requires a small storage space, because everything will be stored in ASCII format or in the values. So you don't need much space for saving such vector data. So apart from this raster and vector data, you have another type of data which is known as TIN, Triangulated Irregular Network. So TIN is a vector based geographic data prepared by triangulating a set of points, treating them as vertices. Now here you can see it is a digital surface where morphological representation is done. The vertices are joined to form a network of edges. You can just see this figure. There are interpolation technique used to construct these triangles. So now you just see these points, basically the red dots, they are the places where we have collected our parameters. But we want to identify what is the value of that particular parameter in these places where we have not done any field investigation. So in that case this TIN data is very useful, because that will give you the interpolated values between these two measured data. So you are going to perform the interpolation here. So here you can see these lines are basically, they are known as edges, and the surface, this is known as convex hull, and faces are these places, right. So these three are very important in this TIN, and the points where you have actual data, they are known as vertices. TIN is used to represent three-dimensional object x, y and z. So this is very useful when we are working with topography. So where we want to generate a digital elevation model. So in that case this TIN is very useful. So using methods of computational geometry, the points are connected into what is called a triangulation, forming a network of triangles. The lines of the triangles are called edges, and the interior area is called a face or facet. While the TIN model is somewhat more complex than the simple point, line and polygon vector model or the raster model, it is actually quite useful for representing elevation, because elevation is the value where you need the local variation, right. So for that we need many vertices, so that you can have more accurate representation of the topography. So this TIN data format is very useful, especially in digital elevation model generation. In TIN data we have certain technical terms which you need to understand. So first one is nodes, the fundamental building blocks of a TIN. The nodes originate from the points and line vertices contained in a input data sources. Every node in the TIN surface must have a z value, then only you can interpolate. Edges are basically every node is joined with its nearest neighbor by edges to form triangles. Each edge has two nodes, but a node may have two or more edges. because edges have a node with a z value at each end. It is possible to calculate a slope around the edge from one node to another. Here you can see the triangles. Each triangular facet describes the behavior of a portion of the tin surface. The x, y and z coordinate value of a triangle's three nodes can be used to derive information about the facets such as slope, aspect, surface area and surface length. So, these are some terms which we frequently use while working with tin. The next is hull. The hull of a tin is formed by one or two more polygons containing the entire set of data points used to construct the tin. The hull polygon defines the zone of interpolation of the tin. So, the next point is topology. The topological structure of a tin is defined by maintaining information defining each triangle's node, edge number, type and adjacency to other triangle. For each triangle, a tin records the triangle number, the number of each adjacent triangle, the three nodes defining the triangle, the x, y coordinate of each node, the surface z value of each node, the edge type of each triangle edge, hard or soft. Topology basically deals or it records or it keeps a record of all the associated boundaries or the points or the surfaces to define the location position of a particular point. Now, let us see how we are representing our data in case if we have raster data, vector data. So, which one is more close to our real surface, right? So, when we are dealing with that, you can see here when we have raster data, so it will have all the pixels and where you can depict the continuous changes, right? But when we are talking about vector data, we can mark the boundaries of some features, right? And in the real world, we have both together because some of the classes they are changing slowly, but some of the classes which are changing abruptly. So, vectors are good to decide or define the boundary of any class, but the local variation can be better depicted by this raster. So, if you want to display or represent your study area in better manner, then you are supposed to integrate this raster and vector together so that it will be close to your real surface. I hope you have understood that with raster and vector we can add some other parameters also apart from the digital number and vector polygon ID. So, what are they? How do we do that? So, they are actually known as attributes. So, they are the additional information available in this particular polygon. So, you can see considering this is our map, right? This is the boundary of your map. Now, here you can see this is class 1, this is class 2, this is class 3, this is class 4, 5, 6, 7 and 8 and the last one is 9 here. Now, by looking at it, can you say what are the parameters attached to this particular map? No, because as per this class 1 is represented with this color, 2 with this color, 3 with this color and we do not have any other information. But when we are having or when we are dealing with attribute, we can add many more columns apart from this unique ID or class number and that can be used to represent this area. In this attribute table, you can see there are some information which are not available in this map, but in this table they are listed. So, if you see this ID 2, right, so 2 is here, so the area is this much. So, this is one example, this is a dummy data, just I wanted to show you how these attributes look like. So when you are having this attribute, and suppose you are having a column of area, so this is the area for this ID 2. So this is the area covered by second class, then third is this much, and the value of this particular partial is this. So such information or such attribute table you can create. I can give you some other example, like you have a point map and they represent some location in some area, and for these point you have collected some information, like first information is unique ID that you cannot change, so that will be fixed. So all the values will be decided and updated on the basis of UID. Now here the first will be your area, let us say what is the population, what is the quality of air, right, air quality, water quality, what is the depth of your groundwater. So those information you can make a table and you can attach to that particular point map, and then using this point map you can run a query, or because all the values are in the background, you have all the values whatever you have collected, maybe thousands of parameter for a single point. So if you want to identify, give me a location where x parameter is less and rest are high, right, or x is minimum from all the collected values. So such queries can be run on this particular database and you can get the answer. That is very easy. So this is the advantage when you are dealing with vector and raster data in GIS environment. I have already discussed this topology in TIN, but now let us see what is the utility of this topology in vector data, because this topology is very important in all different types of vector data. So a GIS topology is a set of rules and behavior that model how points, line and polygons share their geometry, right. So here the same map I have put here. Now you can see this particular edge, this is shared between 1 and 2, and this particular 2 is sharing this boundary with 3. So how exactly we are saying that, okay, this line is shared between 1 and 2 and this line is shared between 4 and 2, this line is shared between 4 and 5, and this line is shared between 4 and 7, and 8 is inside this 7, or 7 is sharing or right hand side of the 6. So all these location parameters, how do we define? We need this topology to define the area or a point where exactly they are and how they are placed. So for example, adjacent features such as two countries will have a common boundary between them. They share this edge. The set of country polygons within each state must completely cover the state polygon and share edges with the state boundary. Otherwise, they will be falling in some other state, right. So those things can be defined by or can be stored by defining this topology. A collection of numeric data which clearly describes adjacency, containment, which is basically coincidence, and connectivity between map features, and which can be stored and manipulated by a computer. This also says a set of rules on how objects relate to each other. Higher level objects have spatial topology rules, like here you can see that A and B, they are sharing this E line, right. So polygon A and B have shared node C, so this is node C, and D, right, and edge E. So this yellow line is edge E. Here line A and B have endpoint node C, right. So this is node C, D, E. Line A and B shares node E. So A and B share E. So that is how we are defining this topology of any given vector data. Here I want to show you a typical structure what we follow in GIS. So in GIS process we start with by defining our problem. So we define what is our objective, what we exactly want to do, and then we define what are the criteria we are going to follow to achieve this objective or aim of our study. Then we have to build the database. So basically you will collect the data, you will process them, and then you will bring them into GIS environment. Then you will perform the GIS criteria whatever you have decided here, right. Now the next one is output, where your output can be seen or you can represent your data in this result. Once you get the result, you can apply your understanding about that area or about that problem, and then you can take the decision. And once you have done that, then it will be the complete circle which we follow in the GIS. So here we start with defining problem and we end with this decision. So you have seen earlier that in GIS we have a flexibility, we can bring different information together. So here you have one example. In this map, these points are basically representing the capitals. Here you have a state boundary, here you have water boundaries. So you have lakes or rivers or maybe small ponds, then you have road networks, and then you have river boundaries or rivers. Now individually if you see them, they have some information, but can we bring them together? If so, then it will make more sense. So then ultimately what we do, we bring them together and then we prepare our output so that we can easily identify what are the different states are having more water or less water, right. So at least those information can be interpreted immediately. Here in GIS we have learned what are the basic structure, what are the different data types, how we use them. Now let us see what are the different application areas where we apply this GIS. So first one is urban planning and management. You can just read this. Then environmental science, political science, civil engineering, business, education administration, real estate, healthcare, and there are many more which I cannot make a list because that list is endless. You can just remember GIS gives you a flexibility where you can integrate the spatial and geographic data and you can perform any type of analysis. So that is the advantage when we are dealing with GIS. In GIS, there is a very important function which is known as spatial data analysis. So spatial data, again we are talking about the data which has latitude, longitude, the positional values. Without that, they are not qualified in this spatial data category. So in GIS, we can perform this spatial data analysis. So what type of relationship exists between geographic features and how do we express them? That we can do with this spatial data analysis. To understand spatial relationship and patterns, we need to perform this spatial data analysis. So spatial analysis to understand our world, mapping where things are, how they relate, what it all means, and what action to take. So everything can be done by this spatial analysis. For geographic pattern, finding optimum route, site selection and advanced predictive modeling. With this spatial data analysis, you can do many more things. So first one is understanding where is my office located. Nowadays it is very easy with the Google Earth or Google Maps. You can simply write the name or maybe latitude, longitude. It will tell you where exactly it is with respect to this whole world. Where are my delivery trucks are. So you can just place a GPS locator in your truck and then you can monitor all the time how they are moving, where they are stopping and how much time they are taking to reach a particular position. Understanding where is about putting the world in context. Measuring shape, size and distribution. How long is this river? How tall is the building? So those things you can easily do with this GIS. Determining how places are related, which river are within 10 miles of a pipeline, have other crimes occurred at this location, finding the best location and path, the best route to travel, the best corridor to build a pipeline or the best location to site a new store. So nowadays it is very common, whenever we want to reach a place, we type the name of that place or the latitude, longitude of that place in Google map and then we see how many routes we can follow and which is the shortest one, which is having more traffic or less traffic. So that we are always using in our day-to-day life. Detecting and qualifying patterns. Where are clusters of high expenditure and on electronic goods? Where are the hot spots of cancer deaths? Making predictions. How will a forest fire spread based on vegetation and wind? How will store size and travel distance attract or detract customers? So those things you can easily do with GIS. So there are different functions which I want to highlight, which you can always perform using any GIS software or you can do it your own by using a programming language, right? So let us see what functions we commonly use in remote sensing and GIS. So let us assume these are the vector points and buffer means you want to create a buffer from a center of a place. So from this point I wanted to create 1 meter buffer. So this is the output. So here you have vector points and you can see how they look like after putting the vector layer. So it is very easy when you are dealing with the GIS. Now the next one is line. So suppose this is a river, right, and you want to create a buffer so that all the buildings or all the settlements should be away from that. So you decided to keep maybe 10 kilometer. So using that you can create this buffer and you can instruct people not to build houses in these places. Next is polygon. So here in the polygon also you can create a buffer. So this is your buffer depending upon your requirement. So such buffer you can always create and it will be very easy when you are working with GIS. Now the next one is spatial overlay function. So A disjoint B, A contains B, A overlaps B, A is inside B, A touches B, A covers B, A equals B and A is almost covers B. So these kind of functions you can always define in GIS environment. Now let us see what are the utility of this spatial overlay function in our remote sensing application. So when you are involved in some project where you want to use this remote sensing data, how exactly this GIS is playing a role. So let us assume you have derived a map by using some classification technique, some data, and you have this is map, output map. Don't see this input. This is the input for this function, erase function. But when you are dealing with this classified map which has been derived from a satellite data, but somehow you feel that this particular area is not relevant, or maybe a particular class is not relevant to you or in your project, then how do you remove that class from your output? So then we have to define a erase feature, and then you can get this kind of output. So assuming a problem where you have generated the land use land cover and you don't want a class for water. So then what you will do? You will digitize all the water boundaries in GIS, and then you will create that as a erase feature or maybe a mask, and then you will mask out this original image, that means your classified image, and then you will get your output without that class. So this kind of application you can always think of in remote sensing and GIS. Next one is identity overlay. So used to update the existing database with additional information. As I told you, in GIS we always talk about the spatial data, and in case if you are having land use land cover map and every time you want to update your map as per the change in the land use land cover, then how do you update? Maybe from this classified map you found that only these two classes are basically extra. So in that case what will happen? You will run this identity overlap and you will find that all the additional feature boundaries are coming on this particular input image. So this can be done by using this identity function. Now the next one is intersect overlay. So used to extract information from the database. So here the intersect means it will give you only for that layer, you can see. So here you can think of one application. You have a land use land cover map from an agency, maybe let us say from NRSC, you have purchased that land use land cover map, and then you want to only perform some analysis for your study area. That may be only 1 by 1 kilometer, but whatever you have purchased, it may be for 1000 by 1000 kilometer. So 1 by 1 kilometer you will make a mask, this intersect feature, and then you will run this and you will get only the classified or the land use land cover map for this particular area. The next function is union overlay. Here it is used to update the existing database with additional information. Aerial extent includes both of them. So here you can see this is the input and this is basically your another layer. So here what you want to do, you want to union them. So then your output will have these feature plus the original feature, right? So both are updated. So this kind of application you can think of when you are using or working in GIS. The next one is update overlay. So used to update and generalize the existing feature or database with additional information, and here the area may also get changed. Why? Because you are going to update. So here this is your original image and these features are basically extra. So you want to update the original map with this one. So here the output will have extra features apart from this boundary, whatever it was, right? So here the features are also updated and the area is also changed. So it depends, like if your both the layers are of same area, then you may not have any aerial extent change, but if they are different, then this condition may arise. So that's all for today. Let us see more about GIS in my next lecture. Thank you.